For 1 billion years, the universe produced no light, not a single photon from any star, any galaxy, any source. The entire cosmos was completely dark. We have almost no idea what happened. We know what came before. For 380,000 years after the Big Bang, the universe was a glowing fog of charged particles, so dense that light could not travel freely. Then it cooled below 3,000 degrees. Electrons combined with atomic nuclei. The fog lifted, but with transparency came total darkness. No stars had formed yet. No galaxies existed. Nothing capable of producing a single photon. The only light remaining was the fading afterglow of the Big Bang itself, stretching into invisible radio waves as space expanded. We know the universe emerged from this era filled with stars. What happened in between has never been directly observed by any instrument ever built. Think of it as a crime scene with no witnesses. The universe entered this period as a vast sea of neutral hydrogen gas. That picture was first described by the physicist Philip Peebles, who calculated how the early plasma combined into neutral atoms. As space expanded, this gas cooled and spread thin. For tens of millions of years, nothing changed. Just hydrogen. Drifting, then something shifted. Gravity began pulling that gas into denser and denser pockets. Atoms pressed together until nuclear fusion ignited. The first stars may have been born sometime between 100 and 200 million years after the Big Bang. 180 million years later, a radio antenna in Western Australia called EDGES detected a faint signal centered at 78 megahertz, corresponding to the universe at exactly that age. If confirmed, it would be the first observational trace of the cosmic dark ages ever recorded. But the signal was twice as strong as standard cosmological models predicted. Physicist Rennan Barkana proposed that hydrogen gas may have been interacting with dark matter during this epoch. That idea remains debated. But the dark was ending. The James Webb Space Telescope discovered galaxies with fully mature stellar populations far earlier than anyone expected, at redshifts beyond 10, compressing the timeline from darkness to light. And Planck's satellite data placed the midpoint of reionization at a redshift of roughly 7. 8. The universe's transformation from neutral to ionized hydrogen was largely complete by 1 billion years after the Big Bang. Here is what makes this unsettling. No telescope has ever directly imaged the cosmic dark ages. Every fragment of evidence, the radio signal, the reionization patterns, the background radiation, is indirect. We are reconstructing a billion-year chapter of cosmic history from residual traces alone. Proposed lunar far-side radio arrays could one day detect the hydrogen signal directly. None have been deployed. The era remains observationally locked. This means the longest chapter in the history of the universe is almost entirely invisible to us. The bright, star-filled cosmos we inhabit is a recent and temporary state. Before the first stars, darkness lasted over 100 million years. And as the universe keeps expanding, stars will exhaust their fuel, galaxies will fade, and the cosmos will eventually return to permanent darkness. Most of cosmic history is, and will be, dark. We live inside an anomaly, a brief window of light between two darknesses. The fact that we can detect a faint radio echo from the universe at 180 million years old, that we can even ask what happened in the dark, is remarkable. Every atom in your body was once part of that silent hydrogen fog. The darkness shaped us. We simply cannot see it.